Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Shahir Mokhtar 1629701, and my supervisor's name is Dr. Siti Noratikah, the teacher Deraman. And for this final year project 1, my topic is the distribution of wind pressure coefficient on the residential house due to different roof shapes using wind tunnel test. Okay, basically, Malaysia is located in southeast inwards map. So Malaysia will experience the wind impact on the system and its coast. For the outline of this presentation, first I will talk about the problem statement, and the second one I will talk about the objectives, and then the literature review and methodology. And for the first one, for the public segment, from the record of the reports of natural disaster occur in Malaysia, windstorm damage and fail most of the building houses, especially to the roof truss structure. This is because of the weaknesses of the joints of truss to withstand the wind load. So the strength of the joint is very dependent on the shape of the roof. The example of roof failure due to strong wind happened in 27 January in 2010. 350 houses in Sungai Petani, Kedah is demolished. As we can see in the pictures, there is roof damage, roof collapse, uplift roof, and failure in the truss structure. Also happened in 12 April 2010. 200 houses in Baling Kedah have damage in roof structure. Next is the objective. The first objective of this study is to study the factor that lead to the damage of urban houses in Malaysia. The second objective is to evaluate and provide the data in constructing two different types of models. And the last objective in this final project 1 is to determine the value of wind pressure coefficient on the residual house. For the literature review part, the first reference is by Zhu and Reardon in 1998 using wind tunnel test method. Their finding is they experimented 3 heat roof design with roof angle of 15, 20 and 30, and found that the angle of 30 roof design will have the greatest airflow at the roof edge. So my comment on this article, 30 roof model are also known as the gable roof, because most of the gable roof use 30 angle of 30 roof model will have the best suction of wind at the roof corner. And the second article is by Prasad EKL using wind tunnel test method. They conducted a study and took gable roof, hip roof, flat roof buildings into top. Okay, so it can be concluded in this article that gable roof will give good resistance to the wind load onto the structure compared to hip roof and the flat roof. The third article is by Davison EL in 2012. They use wind tunnel test method. In their article, the findings is a study of roof trusses in order to compare the gable roof and the flat roof have been made. From the article, I can comment that it can be proved that gable roof will have a good truss structure compared to the flat roof, which doesn't have the truss structure. And the last article is from Chang and Meroni in 2003 using wind tunnel test method. The flow patterns that develop around individual buildings govern the wind forces on the building and the distribution pressure about the building. So it can be seen that the location and the arrangement of building affect the wind flow pattern of the area. So the gap between the previous research articles and my research in final year project 1 is um, the previous research focus on the houses in snow country, but my research focus on Malaysia. Malaysia roof style. For the roof, the previous research compare the difference between roof pitch. They compare different angle, and my research compare between two type of roof, which are the gable roof and the hip roof. And the previous research focus on the roof truss structure only. But my research focus the overall of the roof structure. Okay, for the flow chart, from the start, first I will evaluate the factors affect the roof damage of the house, which are the roof height, roof pitch, and the roof shape. And then provide the data from the actual building, the dimension and so on. And then the design and prepare the models data. First, I calculate the blockage ratio. Blockage ratio formula is the area of the model over area of the wind tunnel times 100%. And when from the blockage ratio, I find the scaling of the model. As can be seen here, this is the actual house and this is the model house. Okay, and the scale between the actual house and the model house is 1 to 40. And the blockage ratio from the formula, I get 2.61%. It is okay. For the conclusion, two of the objectives in this study, which are to study the factor that lead to the damage of urban houses in Malaysia, and to evaluate and provide the data in constructing two different types of model, have been achieved in this study, in this final year project 1. The second objective is this complete in chapter 3. For the other one objective, which is to determine the value of wind pressure coefficient on the residual house, not being achieved yet, but it will be included in final project 2. Okay, for the future work, the model have been designed in final project 1. So in final project 2, the construction and testing of the model in wind tunnel, experimenting the distribution of wind pressure coefficient on the model in order to determine the wind loading on the residential house. And for
the Gantt chart for future work, in week 1, we'll have discussion with my supervisor, Dr. Siti Noratikah, and week 2 is the material preparation by material and also on, and the construct material, the design analysis from the design from final project 1 in week 3, and the construction of model in week 3 and week 4. So when it's finished, I will finalize the model in week 4, and then the testing of the model in wind tunnel. Okay, the test will run in week 5 and week 6, and then we'll have the result in week 6. Okay, and I will have the discussion of the result in week 6 and week 7.
And the last one is the report writing and presentation in week 10 until week 14. And I think that's all from me, and thank you